Hey, good afternoon, everyone. Thank you for making it to this session. We're going to be talking about OpenStack Upgrade Strategy and the fast-forward upgrade specifically. So first, we're going to give some introductions over here. We're going to talk about OpenStack lifecycles and the fast-forward upgrade and wrap up some thoughts and question Q&A. We invite you to get on the Etherpad. If you have some questions during the presentation, you can start asking them there. We'll endeavor to answer them right now or later. Oops. So I'm Maria Bracho. I'm product manager for Red Hat OpenStack.
I'm Lee Yarwood. I'm a software engineer, normally with the compute team, but this time with the upgrades team.
All right. So last summit in Sydney, we talked about OpenStack lifecycle and the feedback received from users and community. And Red Hat, we also polled our customers and we talked to users. And if you've been reading the mailing list, you see that the needs of the community are very real around maintaining stability and also requiring new features, especially around the lifecycle and support of OpenStack. So when you think about upgrades, your strategy needs to meet what do you need in terms of features, also when do you need them, and how. And how you can achieve them in the community, there are several ways. One is you do it yourself, and that is whether you have your own distribution or you use a distribution provided by the community using a deployment tool, or you engage with a distribution from providers like Canonical and SUSE or Red Hat, and then they provide as well a lifecycle management. So they support OpenStack for different lifecycles as well as provide tooling to guide you from one release to the next. During this presentation, we're going to focus on the answer to addressing the specific lifecycle, which is that of Red Hat OpenStack, but we hope that you can use some of these findings and apply that to your particular strategy, even if you're not a Red Hat customer. So in December 2016, we introduced our first long life release, and that was Red Hat OpenStack 10. Which is supported for a minimum for 3 years, extensible to an additional 2. And at this summit, we are announcing that OpenStack 13 will be our second long life release, and will be supported as well for 3 years, extensible for 2 more, and it's based on OpenStack Queens. This takes you, when we introduce another long life release, it also created the necessity to give you a path, give our customers a path to move from a long life release to the next. And this is why we're doing here, talking about the fast forward upgrade. We created this particular life cycle to address the needs of our customers that were both demanding stability and also demanding fast features and new features provided by the community. So we created this track where a customer can stay in a long life release for a longer period of time or in a just regular release for a shorter period of time. Also this month, OpenStack 11 came out of support. So that is important to have this path to upgrade as well. And so we introduced the fast-forward upgrades. In this case, fast-forward upgrades take customers between long-life releases. This is the first for Red Hat OpenStack using Director based on Upstream 000. And we're using Platform Director and aiming to change the game for our OpenStack customers. With this feature, our customers can choose to be on the fast train and get all the features from Upstream every 6 months, or remain in a designated release, like 10, for example, and no longer feel the need to be on a treadmill to make changes so often, and then smoothly change into the next supported long life release, which is OpenStack 13. Okay, a couple of things that we're going to talk about in this presentation about upgrades. There are different procedures that address different needs. There's the update procedure, focusing on operating system changes. For example, in the case that we're going to talk here, it covers the upgrade of Red Hat Enterprise Linux and OVS. There's also another procedure, which is an upgrade procedure, is what we do to move from one release to the next, the M+1 release. We're not going to talk about that today. Nothing that we reference here is specific about this procedure. And then we have the fast-forward upgrade procedure, which is exactly what we will cover, but it leverages the update procedure to actually take you to where you need to be supported in 13. And I'll pass it on to Lee to cover the overview.
Thank you very much. Okay, so we're going to give you an overview of the fast-forward upgrade procedure now. Before I do get into any kind of detail, I just wanted to ask for a quick show of hands if there's anyone in the audience who has never deployed an environment with TripleO. Okay, so there's quite a few hands. So this slide is just a bit of an introduction to what you can expect when you actually deploy an environment with TripleO. We end up essentially with two environments. We end up with an undercloud that is actually providing the management of an overcloud. It's an operator cloud essentially, so it's used to deploy the initial cloud for day two operations afterwards, such as upgrading and fast forwarding, and also scaling that over cloud. The overcloud is the tenant cloud, and that's where workloads are actually going to be running. It's actually made up within TripleO of various roles. Now, when I'm talking about roles today, I'm just talking about the default roles that ship with TripleO, so the controller role and the compute role. I'll also be talking about a Ceph role as well. You can have composable roles, and these roles essentially contain the various services that make up your overcloud. So for the controllers, obviously, you have your OpenStack control services. You have infrastructure services as well. For the compute role, you obviously have Nova Compute, the L2 agents, things like that in the, within the services. So the environment I'm going to be fast forwarding is pretty basic. This is a very simplified diagram that I'm going to keep referring to throughout the talk. You can see you've got the undercloud single node director. I should have said, sorry, director is the downstream name, term, nickname, whatever, of the undercloud. So I could refer to it as the undercloud or director. It's the same thing. The overcloud has a 3-node control plane, so they're controller role nodes. 2 computes. The small blue boxes that hopefully are clear are the workloads that are running on those computes at this time. And then you've got 2 Ceph nodes there providing object and block storage to the environment. The environment is running OSP 10, the Newton-based release of OpenStack platform, on a base of Red Hat Enterprise Linux 7.3 to begin with, using Red Hat Ceph Storage 2.0. Obviously, we want to skip ahead, not 1 release, not 2 releases, but 3. So we're going to end up on OSP 13, our Queens-based release, with an underlying OS of Red Hat Enterprise Linux 7.5 and Red Hat Ceph Storage 3.0 as well. Before I go any further as well, I just want to highlight that this slide deck is for illustration. It's not documentation. There's extensive documentation on the way, both upstream and downstream. There's a work in progress patch here for TripleO that's introducing the user-facing documentation for FFU. That's very well progressed and very extensive already. The TripleO docs website also contains developer docs that I'll reference later in the presentation. They're in progress still at the moment. Both will be published soon. The OSP documentation hasn't been published yet. Obviously, we've announced OSP 13. We haven't released yet. There are a couple of beta documents that are listed there at present, but this is the URL, the location where you'll find the published FFU documentation once it is actually released. So at a high level, there are 6 steps that we're going to talk about today for FFU. Backup being the first one. Update, as Maria was saying, is the second. I will probably refer to it as minor update, just through force of habit. Undercloud upgrades, a preparation step ahead of the overcloud upgrade, and a final converge step. So the initial step, as I said, is backup. We will be providing Ansible playbooks to help with this at release. The manual backup steps are also going to be documented at release within the documentation quite extensively. There is actually documentation upstream already for TripleO in this regard for backup and restore. Parts of this process will need to be repeated later on as well. If I just quickly go back to the 6 steps here, the steps that are in, I don't know if you can see that very clearly, the first 4 steps are in a lighter blue, and these can happen well in advance of the overcloud upgrade itself. If enough time does elapse, we are going to be recommending that people obviously take additional backups, deltas, etc., just so you have a recent backup to revert to if anything does go wrong. Another thing to highlight here, just in this on this slide, is the availability table on the right-hand side. So this is referring to the director's or undercloud's ability to fully manage the overcloud at any one time, the control plane, if that's up, down, inaccessible, etc. The data plane, so your L2, L3 networks, go away, sorry. L2, L3 networks, access to storage, to block storage, etc. And finally, workloads if they're up and running. So the initial first step, really moving forward with the upgrade, is going to be a minor update. This is for both the under and over clouds. And this is the step where we're going to be moving the base OS from 7.3 to 7.5. Because that requires a reboot, we're also going to be introducing OVS 2.9 at that step as well. And you will also be able to pick up QEMU, libvirt, anything else that, while QEMU and libvirt don't require reboots, they still require moving workloads off and bringing them back on. So yeah, anything that requires either a reboot or workloads moving around will be introduced at this step, just to avoid us having to reboot later on in the process, just to keep things up and running and your workloads running, more importantly. So the undercloud upgrade is, undercloud update is relatively trivial. You're stopping a couple of services, updating the TripleO client package, Python TripleO client package, and then running an undercloud upgrade and rebooting the node, obviously. For the rest of the overcloud, it's a rolling update. We have a HA control plane here in this example, so we can go one at a time through the control plane, ensuring that the other 2 nodes remain up and that we still have a control plane during this. When it gets to the computes, you'll notice that down on the availability table, there's a star next to workloads. Obviously, you need to be able to live migrate your workloads around and move them off the compute that you're rebooting, otherwise they will go down. You also obviously need to be able to move the storage from one compute to another. Block migration is obviously a way of doing that, but if for whatever reason you can't in your environment, your workloads will go down during that. We'll target a particular compute node here, update, reboots, and then target the other, moving workloads around, playing migration Jenga, and eventually just rebalance things afterwards. Hopefully this isn't anything new to operators of OSP, OpenStack in general, etc. There's existing documentation that I've listed down here at the bottom that goes into considerable depth on this topic. Then, oh, sorry, yeah, that's where that went. Obviously, the Ceph nodes as well can be updated at this step and rebooted. And again, that's rolling. The data plane shouldn't be impacted, assuming the Ceph cluster is being set up accordingly, obviously. Okay, so we now move on to the undercloud upgrade. And again, this is something you can do well in advance of the overcloud upgrades. The director undercloud will not be able to manage the overcloud when we get so far through this upgrade, when we get to Pike and beyond. But yeah, it's still something you can do well ahead of time if you don't use the director undercloud daily, weekly, etc. to scale or to introduce new nodes into your environment. The actual process of upgrading is pretty straightforward. The process is different than that of the overcloud. The way that the undercloud is configured, installed, etc. is different to the overcloud for 10, 11, 12, 13, thus the different kind of code path here. It's the same pattern repeated for each 3 of the releases, but it does get a little easier as we go through due to some improvements we've made. But for 11, it's essentially stopping the services mentioned here, adding a repo, updating a set of packages, and running the upgrade, undercloud upgrade command. For 12, it gets a little easier, but just enabling a repo again. You can see why I've said this isn't documentation, because I'm using a bash variable there to denote the repo name, just to fit it in. A simple package update and another undercloud upgrade again. And for 13, it's the same command again. This gets the undercloud to Queens, to OSP 13. Again, no management of the overcloud at this point, direct management. So now that the director undercloud is upgraded all the way to Queens, it understands what a Queens overcloud looks like. It understands that for a Queens overcloud, we're going to be moving to container-based services. With OSP 12, with Pike, we moved from bare metal services to containerized, making this fast-forward upgrade much more interesting as well. But ahead of any overcloud upgrade, we obviously have to tell the undercloud where to look for images, where to look for containers, where the registries are actually based. So we have 3 options available to us that are well documented at this point. We can point the undercloud directly at a remote registry, so at access.redhat.com, well, registry.access.redhat.com, for example, over the internet. We can actually use the undercloud itself as a container registry, and we can also use a local but separate satellite system as a container registry as well. Once we've actually figured out where the containers, the registry is going to be located, we can then prepare for the fast-forward upgrade portion of the upgrade. The command line here is obviously very different to an actual one that you'd be running in your own environment. You need to provide all the environment files that you use with the initial deploy of your overcloud here. There are some gotchas around CLI options being deprecated between OSP 10 Newton and Queens with OOO that you need to be aware of. And you need to translate into parameters that you provide through an environment. And finally, you also need to provide the location and details of the various repos that you're going to be pointing to at each stage of this upgrade, the fast-forward upgrade. With the normal major upgrade of n to n+1, that's 1 repo, but obviously with this example that we're going through, that's 3. So it's not just a simple script, I think, as we have with major upgrades. It's a JSON blob of information at the moment that we're providing. That plugs into various backends that we've got, so subscription manager, et cetera, so that then goes through and connects the different repos at each point as required. The container registry file is obviously pretty straightforward. That's just where the images are located, if that's remote over the internet, if that's local on the undercloud, if that's in a satellite system within your network as well. At this point, the undercloud has a good understanding of what the overcloud looks like, obviously, what it should look like for 13. The heat stack has been updated, and we can actually generate the outputs ahead of time that are going to be used to drive the fast-forward upgrade and the upgrade itself all the way through. Overcloud config download is a really useful command. It's going to be a useful command for operators to use just to peek under the covers and see the raw Ansible that's going to be used, how the playbook is actually formed, the various tasks that are going to be run at each step. The developer doc at the bottom goes through this in more detail. It's not a single playbook file, unfortunately. I think it's about 6 or 7 different files that are located throughout a small directory-based, it's not a file system, but yeah, it's just downloaded into a set of directories. The document sets out in more detail where to find the task for each role, for example, and it actually lays out the outer and inner loop that essentially drives this whole fast-forward upgrade, the outer loop being the release, the inner loop being a set of steps that we run through. The first couple of steps applying to all of the nodes in the environment, the second set of steps applying to a single node for each role that we bootstrap and move through, but you'll see more of that on the next slide. Okay, so now that we've prepared everything, we've reviewed everything, we've potentially taken an additional backup if needed, if enough time has elapsed. We're now ready to run through the fast-forward upgrade portion of the upgrade. We start with, across all nodes, across all roles, stopping all of the OpenStack services. That's why there's nothing, there are no red X's against the Ceph nodes here. It's just the OpenStack services that we care about. With that done, we then pick a bootstrap node for each role, and we move that individual node through each of the versions. So we're not skipping anything. It's fast forward, it's not skip level upgrades. So we first move to 11 and then to 12. In this example, there's only the one node that's being upgraded like this because all of the fast-forward upgrade tasks that happen on bootstrap nodes happen on the control plane services. In this example, the control plane is just all of the control role is the default role, so it contains all of the control services. So we're only picking out one node here. If you had a broken out control plane, we would be using one node from each of the roles that contain the control services, and just running the tasks that apply to those services that are within that role on those nodes. Hopefully that made sense. Obviously at this point, the control plane is down. I should have said that with the previous animation. There's no access to the control plane at all at this point, and there won't be until we've actually gone through and upgraded all three of those controllers and brought them all back up. And that's the next step. So the move from bare metal to containers, it didn't force our hand, it just made us move away from doing a traditional, it's not traditional because it's only just been a thing, but a fast forward upgrade all the way through to the target release, where everything is kept down and you bring everything back up with one command. We've had to essentially reuse logic that we already had within OOO for OSP 11 to 12 upgrades, where we were already going from bare metal to containerized services. And we've reused that and the deploy logic there for essentially a 12 to 13 Pike to Queens upgrade and migration to containerized services. We can do that as well with the two controller nodes that are listed at the bottom there that are still on 10, because this is essentially a redeploy. And we're regenerating configs as well for these two nodes. We don't have to move them up through the versions. So everything will be moved, well, on the control plane with this example, everything will be moved up to 13 and then started. The control plane is up, however, it is degraded, obviously. The compute plane is down at this point. The workloads are running still. The data plane is up. I didn't mention that on the previous slide. So yeah, the data plane and workloads remain up during this whole procedure. The compute plane, if it's a separate thing, but yeah, you won't be able to create new instances, etc. at that point. Okay, so obviously the computes are the next thing to bring up in this example, and you can initially target just one node. I think this is going to be documented best practice within our documentation, is to target an individual node, either within your entire environment, within a particular area of your environment, depending on how things are deployed, and to bring that up and as a canary essentially, and just ensure that everything is working as expected. When it comes to the rest of the nodes, you can switch back to using the --roles argument. You can provide nodes, a subset, an additional set of nodes to target, etc. The actual upgrade command itself is pretty, what's the word I'm looking for here? There are a lot of ways of using it and scaling your upgrade as you go through the rest of your computes in the environment. So with the computes upgraded, we can now target the Ceph nodes in the environment. You'll notice that even though we have the control plane and the computes upgraded, Director is still not able to fully manage the overcloud because we still have Ceph nodes that need to be upgraded. The Ceph upgrade is slightly different. What we're actually doing is upgrading the bare metal services in place up to the Ceph Storage 3.0 version. We're then containerizing those services in a second step. So that's why there's two commands here and not just one. It's a two-step process at the moment. We're using Ceph Ansible to drive that. So again, the commands here are not documentations, just for illustration. There's extensive documentation available for this. And you should definitely go through, read everything there. What else was I going to say with this? No, I think that's it. Again, it's a rolling upgrade, so the data plane actually remains up during this as well, and workloads remain unaffected. I think that was it, yeah. Okay, the final step here is the Converge step. So up until this point, the Director under cloud has not been able to manage the overcloud. This final step just updates the stack, the overcloud stack within that undercloud. It just ensures that it has the latest and greatest view of that overcloud, and essentially resets it to a state where it's just like any other OSP 13 Queens overcloud. So we can go through and add additional nodes to it. We can prepare for the next set of upgrades and next set of operations that need to be carried out. Cool, and back to you.
All right, so Lee just showed us how to go through a fast-forward upgrade step by step. This procedure will be out with OpenStack 13. And what we want to make sure that our customers know is that there will be a notification basically prompting you to please try that, contact support, contact your support team, and let us know that you're attempting to do this upgrade, and first try that in a test environment. One of the things that we will continue to do post-GA is to test this procedure at scale, continue to test this with Red Hat partner ecosystem to make sure that any partners that we have that build solutions on top of Red Hat OpenStack continue to work, and that those solutions work not only with the latest release 13, but they also work with the fast-forward upgrade from 10 to 13. And so for a recap as to where we have been here, you saw just now is basically an in-place upgrade. It does not require additional hardware. You saw that it will be fully supported at GA, even though we put enough warnings that we do not want anyone trying this out in production on day one. This should be a procedure that should be tested and planned and coordinated along with Red Hat and along with your operating team. Your team that does operations, and it will include in-service downtime. So probably the most disruptive part of the procedure is still the update that happens in 10. That procedure was introduced back in OSP 7. So it's a procedure that that we know, and Lee talked about that and described when nodes need to be live migrated, or some of our customers actually leverage applications that allow them to move workloads to allow for reboots. So this service downtime is what we have been experiencing so far. This procedure is applicable for long life to long life releases, and right now is very specific to the Newton to Queens jump. However, we believe that this procedure can be expanded to include other targeted releases. And as we mentioned before, we will continue to support it for the life of those releases. Another thing that hopefully was very apparent, that there is no skipping of releases here. Even though we don't necessarily stop at any one release, or the entire cloud is not at one release, there's still code that's been used from all the intermediate releases. There's also no rewind, so backups and restoring from backups are necessary in case something happens. And again, one more time, this is the purpose of this talk was to illustrate how the fast-forward procedure works, but you should read the documentation. Okay. And I think now we're ready for our Q&A. There's, like I said, there's an Etherpad document that's presented there, and I will pause and open it up for questions.
Do you want me to open it up on?
Yeah, I'm going to open it up right here.
I'll show it on the screen.
Okay.
Yeah.
I'll show it on the screen. Cool. All right. The first question is, what are the options for rollback or a partial fail upgrade? Like I said, there's no rewind in this procedure. However, the backup procedure has been not only documented, but it's one of our team members actually automated that using Ansible, that you can customize that procedure for you. And the idea is that the backup procedure runs at the beginning, sort of before even the update. Then after you do the update and you are in your latest version, then there's a step to do that. Right after director node is upgraded, you can back up the delta that you have been backing up, so that you can come back to intermediate steps. But you have to recoup from backup. There's no rollback. Anything you want to add, Lee?
No.
And then the next two controller-based services, such as LVAS v2, continue running during the controller upgrade step? Yes. Somebody's asking for a friend.
Did you just answer that on line 14?
Oh, yeah. Okay. All services are on.
To be honest with the LVAS as a service, with load balancers as a service, sorry, someone's typing as well. I'm not entirely sure. I would assume so.
The reference implementation uses service VMs, so those would be...
They remain up, yeah. So I was just worried that there was something else outside of that that's on the host or something. But yeah, if they're service VMs, they'll stay up and running. Once we upgrade to 13,
so the fast-forward upgrade, again, is for long life to long life releases. However, our customers that are already in 11, we'll definitely support you to an upgrade to 12 and then later to 13. And we can basically coordinate with our customers to make sure what's the best and most appropriate way, less disruptive way to do that. But the procedure right now, the way that it is built and that is basically committed upstream, is focused on the mutants to queen upgrade, so the 10 to 13. All right, so I think the last question is, when we're looking ahead to 10 to 13 to 16, since I presume all the OpenStack services are containerized, are there thoughts towards an automated built-in rewind? Honestly, we have not thought about this procedure yet, to be perfectly frank. There's no blueprints upstream. We just know that we will definitely be supporting this. I am very sure that we'll be leveraging the fact that we have OpenStack services in containers, because why not? So far, great idea. Thanks. We hope you help us collaborate in OOO to make this happen. Anything you want to add to that?
No.
I don't want to promise anything that we don't have. All right. Well, thank you so much.
Thank you.